Let's consider a car moving at a constant speed and ask, what force is bigger, the friction force or the drag force? You might be like, well, doesn't friction slow things down? Yeah, it can. Here, when you're driving a car, how this works is you have a wheel that's spinning, and ideally the wheel's not skidding on the pavement. It's not moving at all with respect to the pavement at the point where it's touching it. And so you have a force from the wheel on the road that's acting backward, which means that you feel an equal and opposite force on the wheel from the road that's pushing it forward as that happens. You can kind of imagine like dragging a thing by a stationary thing or rolling a thing and try and verify that this is accurate. And so this force comes from friction with the wheel and the ground. So that's what we're saying, is that because of that friction there, that's how we're able to move forward. Think about if there's ice and you have no real friction and you can spin out, like it doesn't really work. So we have friction that's pulling ourselves forward. And then you have some aerodynamic drag from trying to drive through air that's pulling us back. And the question here is, if we're moving at a constant speed, which force is bigger, the friction or the drag? Well, if we're moving at a constant speed, that means that our acceleration is zero. If our acceleration is zero, when we look at Newton's second law, we can say that that's zero. That means that the sums of our forces have to sum to zero. When we include both of these forces, force of friction is positive to the right, force of drag is negative in that direction. So if we specify our x direction is positive to the right, this gives us the force of friction minus the force of drag equals zero, or they're equal. So you could have just said, well, since it's not speeding up or slowing down, the net force has to be zero, and that's true. Here, that means that our friction and our drag forces have to be balancing out for constant speed motion. All right, what about the same car, but now we're accelerating? Which force is bigger? I think you should stop and think about that before I tell you. I assume you paused and thought about it. Again, looking at sums of our forces that are equal to mass times acceleration, we can say that since it's accelerating to the right, that means that my net force to the right has to be bigger. So my friction has to be bigger than drag for it to accelerate to the right.